let's solve some radical equations. I'll take us through solving this one, and then I've got one more after this. When you're solving a radical equation, our goal is to kind of free up anything that's under the radical by undoing the radical. So right now, I can't get to the plus 1 to just subtract 1 because it's trapped underneath that radical. So I have to get the radical to go away first before I can try subtracting 1. Well, I know that the opposite of square rooting is squaring. So I could square root to undo the radical, but I need to make sure that the square root is alone first. So I have this 2 that's being multiplied on the front. Since it's multiplying, I'm going to go ahead and just divide by 2 and on the right side as well. And that makes sure that I just have the square root all alone on the left, and then on the right I have my 2. Now, since the square root is the only thing on its side, I can go ahead and square, and my square will undo that radical. And of course, we have to do the same to the right. So x plus 1 equals 4. Subtract your 1, and x is equal to 3. When you're solving radical equations, you need to be super careful because radicals have certain domain restrictions. Remember, we can't have negative numbers underneath a radical. So once you get an answer, go back and just make sure that it makes sense. So I've got 2 times the square root of x plus 1, x is 3, and that should equal 4. So 2 times the square root of 4 should equal 4. I know that the square root of 4 is 2, so this is 2 times 2 should equal 4. And 4 equals 4. That is a true statement, which tells me that my solution is x equals 3. So again, there are domain restrictions when you're dealing with radicals, so be super careful and always check your answers. Sometimes you get down to an answer and it's actually what we call an extraneous solution. It's just a fake answer. When you go back and plug it in, it doesn't actually work. And that's because the solving process doesn't take into account the fact that we have domain restrictions. So for radicals, always check your answer. Okay, let's go through one more. So this one, again, I want to isolate that radical first, and then I'll go ahead and get rid of the radical. So now outside the radical is a minus 1. So let me add 1 to move that to the other side. Now that the radical is alone, I can go ahead and do the inverse of cube rooting, which is cubing. So I'm going to raise this to the power of 3. Whatever power you raise to needs to match your index. So I picked 3 so it matches my index. Those cancel, and I raise the right-hand side to 3 as well. So now I just have 2x minus 9 equals 27, and we solve. So x is equal to 18. Now something nice here is that because we're dealing with a cube root, we actually don't have any domain restrictions. We can take the third root of a negative number. So negative 8, for example, the cube root of negative 8 is negative 2. Because negative 2 times a third negative 2 will give you negative 8. So we don't have those same domain restrictions that we had when we were square rooting. But it is always good to still just check your answer, so I'll go ahead and do that. Cube root of 2 times x minus 9, and then we'll subtract 1 equals 2. Cube root of 36 minus 9 minus 1 should equal 2. Cube root of 27 minus 1, that's 3 minus 1 equals 2, and yep, 2 does equal 2. That is a true statement. So I'll go ahead and box my solution, that x is 18. So that's a little on solving radical equations. Hope that helped. Thanks for watching, and I'll see you next time.